So we're going to let f of x be 3 minus x and x over 2 plus 1. So the first one is if x is less than 2, and the second one is when x is greater than 2. So if we graph this, at x equals 2, the top equation is 1, and we're going to put a hole there since we're including values to the left of 2. At 0, we're going to get 3, and we know the slope is negative, so it should look something like that. And to the right of 2, we have x over 2 plus 1. I plug in 2, I get 2, and here I'm going to put an open circle since we're looking at values greater than 2, and slope is a half. So let's take a look at the limit as x approaches 2 from the right. We're going to do 2 from the left, and then we're going to look at just 2. So if we look at 2 from the right, we're obviously going to be looking at this part of the graph. So if we approach 2 from the right, we approach this hole here, which is at y equals 2. And then if we look at from the left, when we're looking at this graph, we approach 2 from the left, we land to this hole, which is 1. And notice here the left hand and the right hand limit are not the same. So we say that the limit as x approaches 2 does not exist. So in order for it to exist, the left hand and the right hand limit have to be the same. Okay, so let's look at one where the limit does exist. So let's say if I look at the limit as x approaches 4, we'll look at 4 from the left, 4 from the right, and then just 4. So x equals 4 is here, and that's obviously to the right of 2, so we're going to be looking at this function. If I plug in x equals 4, I get 3, so that's over here. And if I approach 4 from the left, I'm going to be coming down from up here. I'm coming up there, and then to the right, I'll be coming down this direction. So in both cases, I'm going to be getting closer and closer to this point right here in the green, which is at y equals 3. So the left-hand limit is 3, the right-hand limit is 3, and since they're the same, we say that the limit is also 3. So the limit as x approaches 4 is also 3. Okay, let's look at another piecewise function. So let's say I have f of x is equal to 3 minus x if x is less than 2, 2 if x is equal to 2, and x over 2 if x is greater than 2. So that's going to look like this. At x equals 2, we said it's 2. And to the left of 2, we have 3 minus x. We know at x equals 0, it's 3. And at x equals 2, it's 1. We're going to put an open circle since we're strictly less than 2. And then we're just going to connect it. To the right of 2, we have x over 2. And if I plug in 2, I get 1. And there we're going to put a hole there. So it's going to look something like that. Now let's take a look at the limit as x approaches 2 from the left, from the right, and then at 2. So from the left, we'll be coming down here. So as we come down here, we're getting closer and closer to this hole, which is at y equals 1. And from the right, we'll be coming down here, and we see we get closer and closer to the same point here, which is at y equals 1. And since the left-hand limit and the right-hand limit are both the same, we say that the limit is 1. Okay. So next, if we instead looked at, let's say, negative 1, so if we look at negative 1 from the left, negative 1 from the right, and then just negative 1, let's see what happens. So negative 1 is on the left here, and we're going to be looking at the function that's to the left of 2. So to the left of 2, that's the top one right here. So if I plug in x equals negative 1, I get 4. So this point here will be at 4. So if I'm coming from the left, I'm coming down here, and I reach negative 4. I'm sorry, positive 4. And if I come from the right, I'm coming up along here, that's also approaching 4. So the left hand and the right hand limit are both 4. That means the limit has to be 4. Okay. Now let's look at a more interesting piecewise function. So let's say we have f of x to be 0 if x is less than or equal to 0, and sine of 1 over x if x is greater than 0. So let's graph this. So when x is less than or equal to 0, we get 0. So we have that nice straight line. And to the right of it is sine of 1 over x. So here, if I were to look at the limit as x approaches infinity of sine 1 over x, well, 1 over x, this inside is going to go to 0, since a number over a really, really big number tends to go to 0. So this is the same thing as sine of 0, which is 0. So eventually it's going to go to 0. Now the maximum this could be, because it's sine, we know sine has to be less than or equal to 1. So the maximum is going to be 1, and that is when sine is pi over 2. Sorry, the angle is pi over 2. So we know that sine of pi over 2 is 1. So here we have 1 over x, so we set 1 over x equal to pi over 2. So that means x has to be 2 over pi. So basically somewhere around here at 2 over pi, we're going to hit 1. And then we're going to come down to eventually 0. And then to the left of 2 over pi, so like if we get really close to 0, we know that it's going to oscillate up and down. So between 1 and negative 1. So here it's just going to go crazy. So it's going to go back and forth between negative 1 and 1. So it doesn't end at a certain point. Okay. So let's answer a couple questions here. What is the limit as x approaches 0 from the right and 0 from the left and just 0? The easiest one to look at is 0 from the left, because that's just this nice line here. So as I approach 0 from the left, I'm obviously going to approach 0, this point right here. So this is 0. From the right is not easy to see. Well, it just oscillates between -1 and 1 forever. It doesn't go to a single point. So in this case, the limit from the right doesn't exist. So from the right, it doesn't exist. It doesn't go to a unique point. So from the left, it's going to 0. From the right, it doesn't exist. Those two limits are not the same, so we say that the limit as x approaches 0 also doesn't exist.